Hey everyone, Mike here from ArnoldTutoring.com with a great analytical geometry question. It says find the minimum of the sum of the distance AC and distance BC if we've got our 2 points AB and then we just know C is on the x-axis. Always a good place to start is drawing a quick picture. So we've got our XY coordinate system. I will draw a point A is at -1, 6, so somewhere like here. And I'll write that A is -1, 6. And we'll draw B over here at 14, 9. Great. Now we know that C is some point on the x-axis. So let's draw it there for now. And we don't know the coordinates, we just know it's on the x-axis. So we don't know the x-coordinate, we'll call that x for now. But we know the y-coordinate will be 0, because all points on the x-axis have a y-coordinate 0. Now we're trying to find the minimum of the sum of the distance of these two lines, AC and BC. So how are we going to minimize the sum of these? Because really our point C could be anywhere along the x-axis, right? It could be way over here, it could be way over here, it could be here. How do we know all of these are going to create two different sets of lines? How do we know which one's going to minimize the two lines? Well, if we look, and this picture actually I've drawn is actually a decent indication. There's two ways we could do it, or our points could be way out to the sides, and we'll see what that would look like. Let's just imagine we're using this point out here. The x-axis obviously continues forever, so we're going to use this green point here, and that would create lines like this, like that, and like that. So you can clearly see that as you pull it out to one side, one of the lines is getting very long, and it may shorten the other side, but it's not going to balance out as nice as the two orange lines there. So our whole goal is to minimize the sum of the two sides, and the way we do that is by making a right angle. A right angle between the two lines is the perfect balance for distance. They're never going to get too far apart where one line's really long, the other's short. They'll both be sort of in the middle, and that balances to create a minimum sum. So how do we get right angles in analytical geometry? You can think of that as perpendicular lines, and perpendicular lines have negative reciprocal slopes. And negative reciprocal just means you flip the fraction and change the sign. So let's find the slope of AC. The slope of AC is going to be 6 minus 0, right? y2 minus y1, or rise, over the run, which is -1 minus x. So we'll call this 6 over -1 minus x. That is the slope of AC, and we would just plug in x when we find out where that is. The slope of BC, as is 9 minus 0 over 14 minus x. So this is 9 over 14 minus x. So here's the two slopes, and we want these two to be negative reciprocals of each other. So I'm going to take 6 over -1 minus x, and I want that to equal the negative reciprocal of the other slope, right? I don't want the slopes to be equal as they are. I want the negative reciprocal of one of them to be equal. So instead of writing equals 9 over 14 minus 6, I'm going to flip that and make it negative. So I'm going to call it 14 minus x, that's on the top instead of the bottom, over -9. Okay, so I've just taken this slope, flipped it, and changed the sign, and I want that to now equal the slope of AC. So if we can hold this true, that proves they're right angles, and that should minimize the distance of the two lines. So I'm going to cross multiply, and I'll get -54 equals 14 minus x times -1 minus x. Again, I just multiplied the -9 up to the 6 and the -1 minus x up to the 14 minus x. Here we could do some quadratic math, but if we don't want to, it's actually quite straightforward. If we just think about values that multiply to 54, you can think about 6 and 9. These are probably going to be integers in a question like this. So how would we make this bracket 6, well, x would have to be 8, and that would make this bracket -9. So we'd get 6 times -9, so that would work. Either x equals 8, or we make the first bracket 9, and that would be done with when x is equal to 5. When x is equal to 5, this first bracket would be 9, second bracket would be -6, so that's the other way it's done, right? Either x equals 8 or x equals 5. So we've solved for our x values. Now we just need to replace them back in to find the actual distance. So let's get the distance formula. The distance between the two are going to be the square root of, we should know our distance formula, y2 minus y1 squared plus x2 minus x1 squared. So for AC, it's going to be x plus 1 squared plus 36, which is just 6 squared. And the other one will be x minus 14 squared plus 81, which is 9 squared. So now we need to plug in x equals 8 or x equals 5. When x equals 8, I'll do that first, we will get square root of 117 plus the square root of 117, which is 2 root 117. Okay, pretty good. Let's do when x equals 5, because that was our other option that gives us also a right angle. D equals 36 plus 36, so it would be the square root of 72 plus the square root of 162. And when we simplify these, we will get 15 root 2. If you have a calculator, we just want to compare these two, and 15 root 2 is slightly smaller than 2 root 117. So that is our answer, 15 root 2. So a few things going on here. Again, very good test of analytical geometry. Creating a right angle between two lines is going to minimize the distance of those two lines, right? And you can think about that as, why does it do that? Why does this right angle minimize the distance of these two lines? It's because if we create that right angle there, then we know the opposite side has got to be the hypotenuse. That's got to be the longest side, right? And we know that the two short sides of a right angle triangle will sum always to a greater value than the hypotenuse, but that's going to be the way to minimize it, is if you get the hypotenuse on the opposite side, which we know it's always opposite the 90. Then it made us say, okay, how do we get that right angle? Well, we need the slopes of the two lines to be negative reciprocals. Set that equal to each other, and it required some algebra. Plug it back in, and then lastly we needed to know our distance formula, which is just Pythagoras, and then compare the two answers we got. Pretty difficult question in terms of how much work. You know, that took us about 5 to 6 minutes just talking through it, but all skills that we should be able to put in place. Hopefully this is helpful. You can always send us more questions, info@arnoldtutoring.com. Thanks.